is to discuss the opportunity for you to save time and money while improving your quality for fresh cheese and Greek yogurt production. My name is Jeff Bodekeimer. I am currently the process sales manager for FOSS and look forward to discussing this application with you today, and hopefully you see a lot of benefit as I have, some of our other customers have, for the ones that have installed this technology. So today what we'll learn is how to save money by reducing protein losses and protein content and total solid content significantly in your Greek yogurt or cream cheese production. Also to increase your yields without increasing your current raw material costs, such as skim milk. Also eliminate sampling errors from your process by avoiding taking draft samples to a laboratory. Also save time by reducing rework in your production. Increase your consumer confidence with higher product consistency. And lastly, decrease cost and time spent per sample if you do currently pull a sample and run it on benchtop instrument. So the agenda is just to give you a quick intro on how you can save in protein or total solids, how a ProFOSS inline analyzer can help you shift your production closer to your target and also maintain better product consistency. Also, I'll show some examples, real-life examples, and additional benefits that the ProFOSS technology can provide. At the end, there will be a short Q&A session that will open up the phone lines and also have the chat box available for any questions. So really with this technology, we're looking at two critical parameters in Greek yogurt. Primarily the protein is obviously very important, where we can help standardize the protein coming off the separator and reducing any protein giveaway, therefore giving you the opportunity to make more money. Also, the ProFOSS can be utilized for measuring total solids in either Greek yogurt or cream cheese. Again, with the total solids control, that's where you have the ability to maintain your optimal moisture content in either the cream cheese or Greek yogurt coming off the separator. So by being able to measure those two, we can help you, avoid a giveaway or any malfunction in the separation process by detecting these changes rapidly in real time, providing results every 20 to 30 seconds. So just a quick intro. The opportunity is very large to make money with this application. Since we are, again, trying to shift your protein concentration or total solids concentration, whether we're talking about Greek yogurt or cream cheese. In the case here, you can see that a reduction in protein can yield up to $100,000 by basically saving your input on skim milk. So reducing the overcompensation of skim milk by basically, cost avoidance in the production process. So how are these results achieved? Basically, we're taking the concept of analyzing things in a benchtop or laboratory environment and bringing that directly in line in the process stream off the separator. So here you can see we have a picture of the analyzer, and it does the analysis in real time, as I mentioned, and we'll do results every 20 to 30 seconds on protein, total solids, and also fat. So when we look at the approach with an inline analyzer, what we're trying to do is reduce sampling error and also reduce the process variation that's occurring in your process. If you use a benchtop instrument today, you have fluctuations in your process that oftentimes you may not be able to detect in a quick manner, especially if you're pulling samples every 30 minutes or every hour. So you have what's called a process accuracy, where you can have the instrument error that's associated with that particular sample. You have the sampling error, and on top of it, you have the fluctuation in your process. So with an inline analyzer, we are trying to basically smooth out the variation and reduce the sampling. This will give you a more accurate kind of frequent process control, reduce safety margin, and increase yield. Also, as I mentioned, give you a more consistent product quality as you will have that confidence of the results coming off the separator in real time. So the ProFloss, where is it used in either fresh cheese or Greek yogurt? It is, as I mentioned, after the separator, post-separation. And why here? We're trying to allow you the opportunity to utilize the ProFloss to make corrections either via manual control or automatic control to the separator by adjusting the flux rate into the separator or the flow rate into the separator. And that will then give you the opportunity to get your targets closer to specification. So as I mentioned, we can provide a signal to an automation PID loop, such as a PLC, and this allows you then to measure and monitor the either photosolids content or protein content in real time, and then adjust, as I mentioned, the flow rate and gallons per hour of fermented milk or cheese coming into the separator. As I mentioned as well, you can do the same with a fermented Greek yogurt coming into the separator to adjust the protein content. That allows you then to react real time to any recipe or fermentation tank changes that might occur, and I'll show some examples of that later on. So here's an example of just an installation point where we have a probe that gets installed in the pipe, and the white mass, Greek yogurt or cream cheese is in the pipe flowing by the probe here, and then we have a fiber optic cable coming back to the actual analyzer itself. And as the product flows past the probe here, it's taking the readings every 20 to 30 seconds. So really, what's important about real-time results? Of course, you can detect many things. If you look at a benchtop analyzer, it will oftentimes not allow you to see trends or slow trends in the process, whereas an inline analyzer, you can see those trends and can react much quicker. Also, pictured on the right here, you can detect serious production issues that may be occurring if there's a blockage in the nozzles in the separator, and you really have the opportunity to make an adjustment, of course, and detect it much earlier on than opposed to a lab instrument here, where you see this case here. There's dots here. These red dots would indicate a graph sample running in on a benchtop. Here too, you can see that in this particular case, there was a separator issue where we're measuring the orange is total solids and the purple is protein. And this blue line here represents when the manual sample was pulled and run on a benchtop instrument. Well, you can see in this time duration, there was a droppage in both solids and in protein, where the ProFloss inline analyzer was able to detect that, whereas if you had a benchtop instrument, you wouldn't have been able to detect it as quick. So there was about 25 minutes of production that was out of specification in this case. Also, increasing yield control is also a benefit of inline analysis. If the separation process is showing problems, you can see these detections or these situations in real time, whether it be, as I mentioned, a blockage in the nozzles, or could be even a fermentation tank changeover or startup. So when we look at the inline analyzer, really what we're trying to achieve is to reduce your standard deviation or your process variation. So here's an example of how we were able to bring a customer and shift their mean by 0.1 closer to target in total solids. And with that said, that then gives the opportunity for more profits in your production and more consistent product as well. Also, here shows a situation where we made an adjustment with a PID loop, where we are running an inline analyzer with a set point of 10% protein, and then there's an adjustment made to the PLC, the set point to 10.125, just to illustrate that the inline analyzer can react to that set point change as well. So again, this is an example of a PID loop, which ultimately is where the most benefit is with this type of device. So here is an example of how you can try to utilize this technology to help shift you closer to your target. The red line would indicate where the customer was at prior to a ProFOS with a mean of 10.25 roughly in the protein, and the green line is where the customer was at after the ProFOS was implemented and installed with a mean of 10.115. So again, shift in protein of 0.10, which doesn't seem like a lot, but when you're making Greek yogurt at large quantities, that really adds up, and it could yield roughly probably $200,000 per year if you can shift in that type of protein level. Here's another example of really just how we're basically shifting the standard deviation in protein. So here is a situation where the standard deviation was 0.18, and after the standard deviation is 0.07. So in this case, really the mean stays the same, but the standard deviation gets reduced in trying to optimize the consistency of the product and ensure product quality going forward to ensure good mouthfeel on the product for the customer, and again not overutilizing any skim milk in the production process. So here's just, I'm going to show a few slides of some examples of how the inline ProFOS compares to graph samples. You can see in this case here, there's quite a bit of fluctuation in protein in the process, and you can see the dots, which represent pulled graph samples from a benchtop instrument. So in this case here, they're using a benchtop instrument to correct the process, and you can see there is an elevation in protein occurring here when they pulled samples. And really, if you're using a benchtop instrument, it's much more difficult, of course, to react or to make the change necessary to make sure you're within your specification. So in this case, there's quite a bit of protein giveaway in this case here. Here's an example of startup, how the ProFOS can be utilized, and some of these slides are just again used for validation purposes to show how things occur prior to a PID loop. So in this case, you can see there's fluctuations during startup before they were able to get kind of back into their control or where they wanted to be, roughly around 9.8 in this case. Another great benefit to ProFOS inline analyzer is the ability to see the fermentation tank change. Here you can see in this case occurred, and right here. So again, providing a tool where the operators can utilize the information much more real time as opposed to a benchtop instrument. And here's an example of just a process that's very stable. So the standard deviation you can see is 0.06. So back to kind of what I showed earlier. Now basically by hopefully seeing some of these slides, you can see that there is opportunity out there to shift your protein. If it is in the case of Greek yogurt, or in the case of cream cheese, your moisture in the cream cheese, to really give you the confidence that you're able to produce the product closer to specification. And as I mentioned, in this case, they were able to yield a profit of $100,000 based on a protein shift of 0.2, with the annual production of about 15 million pounds for this separator. Just a quick few slides about the ProFOS, how it's designed. We use a box that's stainless steel, and it can withstand high temperature, high water, humidity swings. It's also dust proof, and it is all the components we use are USDA hygiene certified. So the product contact, of course, is USDA certified. So really, the ProFOS analyzer is meant for a dairy production plant. It was designed to go in a dairy plant. We also have automatic lamp backup system, meaning that there's two lamp sources in the ProFOS where there's an indication when the lamp changes. So this helps ensure uptime or avoid a lamp failure during production time, so it can be changed during a CIP or more convenient time and after the fact. So why FOS? Maybe some of you are on this call because you currently use a FOS instrument, or you are aware of FOS, but we have been in business for over 55 years, and our focus really has been in analytical instrumentation. And of course, one of our largest segments globally is the dairy industry. We have over 25 years of experience in inline analysis within different instrumentation. We have over 300 inline installations worldwide in the dairy industry. This ProFOS inline analyzer is a third-generation inline NIR. We've learned from different generations on how to apply different technologies and utilize the best technology at hand for our customers. We also have the ability to network software and do remote diagnostics, which is a big benefit especially for an inline analyzer where our customer support can diagnose issues remotely from a faraway place, provided they have access into the ProFOS instrument. Another great benefit is that the transferability of our calibrations from one ProFOS to the next, and this is a big benefit to help reduce startup cost for an analyzer, and also to provide consistency across multiple ProFOSes. If you have a situation where you may have 20 ProFOSes in your company doing the same application, and you want consistency across all instruments. Also, we dedicate a lot of our focus on our service engineers in North America. So we have 38 service engineers in North America to help ensure uptime. We also have, for the process group, an in-house application specialist team, an engineering team, and also a software integration team, which helps the integration from the ProFOS analyzer to your PLC. So when we look at kind of our approach into any segment, or in particular in the dairy segment, we have historically taken the approach that we like to take the best technology for the application at hand. So you can see here we have basically an instrument called a process scan, which is the same technology that's used in Multiscan. So maybe some of you are familiar with that, and that's primarily used for liquid melt standardization. And then now we have our ProFOS NIR technology that's used in many applications, such as WPC, MPC out the US. We also have a powder probe for a drying application, but this particular technology, we've had a lot of success in Greek yogurt and also in of course, cream cheese, not to mention some of the other ones here listed, mozzarella, ricotta cheese, and also butter. So to conclude, the benefits of the ProFOS inline analyzer is we're trying to help you reduce your standard deviation in your process to ensure more consistent product. That would give you the opportunity then to move closer to your target. If you're able to do that, then of course you're able to gain more profits in whether it be a protein parameter or a moisture parameter. Also, reduce sampling and analysis time in the laboratory. It's not a probably a huge savings, but that is a savings where you're able to avoid the manual sampling and any lab time associated with those graft samples. As I indicated before, eliminating sampling error from the process is a key, because it's very much of a challenge to detect the changes necessary when you're doing manual sampling. And this will allow you the opportunity, of course, to get those results every 20 to 30 seconds. So just imagine taking a sample every 20 to 30 seconds and running it on a bench file. How much of a challenge that would be, and what kind of fluctuation you have from sample to sample. Reduce rework. That would, obviously, if you have the ability to ensure more consistent product, then your rework would go down. And typically with the ProFloss, our payback has been anywhere from 6 to 10 months, or 6 to 12 months in that area. So there is a lot of benefit, and in situations now where we're having multiple systems in one program. So with that kind of concludes the session. So I will open it up to questions at this time. I'll also look at the chat box. So feel free to ask any questions or send a question through the chat box.